Here's a recording of some problems from section 3.7 on implicit differentiation. In problems 1 through 7 we have to find dy dx. So let's take the derivative with respect to x of both sides of this equation. Now probably this is more detail than you're going to put in on your problems, but I'm going to show explicitly breaking this down using the addition-subtraction rule. And then from here, I'm going to look at that and say, well, that's a product. So the derivative of x squared y is going to be first times the derivative of the second plus the second times the derivative of the first. And now I'm ready to handle this term, in which case I get first times the derivative of the second plus the second times the derivative of the first. So here we go. X squared, the derivative of y, that's with respect to x. The derivative of y with respect to x is dy dx. Y times the derivative with respect to x of x squared is 2x plus x times the derivative with respect to x of y squared. Well, that's going to be the derivative of the outside, keep the inside the same, times the derivative of the inside. And now we end with y squared times the derivative of x with respect to x, which is 1. Let's clean this up a little bit. X squared times dy dx plus 2xy plus another 2xy, but this one is times dy dx plus y squared. And now let's get all of the dy stuff on one side. Let's get all the other stuff on the other side. Let's factor out the dy dx and then when we divide, we end up getting dy dx is equal to negative 2xy minus y squared all over x squared plus 2xy. Now the book then looks at that numerator and sees the two negative signs, and it factors out that negative, leaving them the final answer of 2xy plus y squared over x squared plus 2xy. Okay, there's problem number 1. Problem number 3. Let's take the derivative of both sides. The derivative of y squared, that's a composite function. Bring the power down, leave the inside the same, and then multiply by the derivative of the inside. This one's going to be a quotient, so it's going to be bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Now since the dy is already isolated, we will just divide both sides by 2y, giving us dy dx is equal to x plus 1 minus x plus 1. See if I did that. Negative x negative times negative 1 is positive 1. Yep. All over x plus 1 squared. And again, dividing this whole thing, or multiplying this by 1 over 2y. Cleaning up the top, those two x's cancel, giving us 2 over 2y times x plus 1 quantity squared, those two cancels, leaving us 1 over x plus 1 squared. Sorry, forgot the y. Y times x plus 1 squared. That's problem number 3. Problem number 5. Let's take the derivative of both sides with respect to x. So the derivative of x with respect to x is 1. The derivative of tan y, that's a composite function. So let's take the derivative of the outside, which is secant squared, leaving the inside the same, and then multiplying by the derivative of the inside, which is going to be dy dx. Now, let's divide both sides by secant, and I get 1 over secant squared y is equal to dy dx. Or, seeing that secant is defined as 1 over cosine, this is really equal to cosine squared y is equal to dy dx. That's number 5. Number 7, again, let's start by taking the derivative of both sides of the equation. Okay, that's the addition subtraction rule. So we'll take the derivative of x with respect to x and get 1. We'll take the derivative of tangent, the outside function, and get secant squared. Let's leave the inside the same. Now let's multiply that by the derivative of the inside, which is first times the derivative of the second plus the second times the derivative of the first. And again, this is all equal to 0. So 1 plus secant xy times the derivative of y is dy dx, and the derivative of x is 1. Let's distribute that over both those terms, and we get a 1 plus secant squared xy times x dy dx plus y times secant squared xy, and that's equal to 0. Let's take this 1 and that term and get it over to the other side, and that leaves us secant squared xy. Typically we put that x in front, and we'll put the dy dx in the final position. A negative 1 there, and a negative y secant squared xy over there. Dividing both sides, we end up with dy dx is equal to negative 1 minus y secant squared xy, and that's all divided by x secant squared xy. And the book then does a massive cleanup job on this. And let's see if I can even get this in the form that they would like it to be in. First of all, they split the thing. It looks like it has a common denominator, so they're going to call it negative 1 over x secant squared xy minus y secant squared xy over x secant squared xy. Alright, now over here we know that we have a denominator of secant squared, so that's going to turn into negative 1 over x times cosine of xy. And then over here, these two secant squares canceled, so it's minus y over x. And that's what they say the answer is. So there's problems 1 through 7.